Alright, so what we're going to do here is we're going to look at complex fractions and kind of look over order of operations. A complex fraction is the idea that we have a fraction of another fraction. Again, this can be thought of a division, or it could be thought of something that was cut into two-thirds parts, which is hard to visualize. I tend to think of them as divisions and use this center dividing as a division. And so there's different ways we can have complex fractions manifest themselves. The sum of some fractions divided by another fraction, which takes these different forms. And they're considered complex because there's fractions of fractions. It looks complicated. And so what we want to do is find a way to work with it. So if we look at this first example, what we'll do is this evenly divided line will make a division. So we'll rewrite this as 1/4 divided by 2/3, which is equal to 1/4 times the reciprocal, 3/2. And so that's 3/8. Now a lot of times, because I know I call this division in my head, I usually jump to the first step of saying 1/4 times the reciprocal of this, 3/2. So I usually skip writing this step. Sometimes if any of you ask me a question in email and I draw you out a little video or draw it out, you'll see that step being skipped. But what you should say to yourself is you should say the division and say the division sign. Another method that can be done is we can look for the LCD in these two, in the two denominators. So I have a 4 and a 3. So the LCD of 4 and 3 is 12. And then I can take 12 and multiply it to the top and bottom. So I'm multiplying it by 1 for the LCDs here. And what this does is this turns it to 1/4 times 12 over 2/3 times 12. And what happens with that is 12 is divided by 4 3 times, and 12 is divided by 3 4 times. And so I change my upstairs to 3 over 2 times 4 is 8. Both of these methods are valid ways of dealing with a complex fraction. Sometimes this is the easier method for the things that you have. And that actually works out a lot when we have variables in the denominator. Now, our order of operations is still the same. We do our multiplications first, then our multiplications are divisions, and our additions and subtractions. So we have our PEMDAS. And the order we do things is down. So we do our grouping symbols first, then our exponents, then multiply and divide from left to right. And then an add or subtract left to right. And so this is the order we'll do things. And inside grouping symbols, we keep the same order. So if I have 1/2 plus 1/6 times 1/3, I have to do the multiplication first. So that's 1 times 1 over 18. Now I need an LCD. Well, I know that 18's LCD 18 is the LCD because I can multiply 1/2 by 9. So I'm going to multiply 1/2 by 1 in the form that gives me the same denominator. And so I get 9/18 plus 1/18. And that's going to be 10/18. But this isn't in the simplest form. They both share a factor of 2. And so I have 5/9. Pull out the 2. I write that as 5 times 2. And this is 9 times 2. 2's cancel out, leaving me with 5/9. Well, let's see. I have 2/3 cubed minus 2. So I have to do the powers first. And what I'm going to do is I'm going to take the power, can distribute to each part of the fraction bar. And now I'll do these. That's 8/27, because 2 cubed is 8, and 3 cubed is 27, minus 2. Well, the LCD I need is 27. Now this has it, but this doesn't, so I'm going to need to multiply this by 1 in the form that gives me the denominator of 27. So I'm going to get 8 minus 54 all over 27, because they have the same denominator. And so this is the bigger number, so my answer is going to be negative. And if I subtract the 2, I get 46. And now I'm left with, do I leave it in this form, or do I write it as a mixed number? And for right now, what we're doing, this is a good form. A thing to notice about fraction bars, especially when we have variables in play, is that the fraction bar or the division bar works like a grouping symbol. So if I have 3 squared minus 4 times 2 over 2 plus 5, my order of operations says do the grouping symbols first. So I have to treat the top as if it's grouped and the bottom if it's grouped. Just writing this symbol groups it into 2 parts. So I go upstairs and I do my 9, because I do my exponents first in my upstairs. And downstairs, 2 plus 5 is 7. And I come up here, and well, 4 times 2 is 8, so I'm going to get 9 minus 8 over 7, or 1/7. So just be careful when you're doing your order operations. Realize that the fraction bar itself gives us a hidden grouping symbol. And so this is what complex fractions look like and how the order of operations manifests with fractions. What we're going to do now is we're going to look at equations that have fractions in them for the next section.